let's get started. So just a little bit about me. I'm Matheus Cardoso. I'm a developer advocate and iOS engineer. I'm based in Brazil, and today I'm working as a developer advocate at Stream. We are a company that builds feeds and chat SDKs, and we have a strong developer relations team that's always building awesome open source stuff. And today I'm kind of presenting one of our projects. So yeah, working on a lot of on open source, writing a lot, and doing lots of community stuff. And yeah, of course, I build a lot of stuff using the Swift language. It's the main language for iOS development, and you can also use it to write on Linux. You can use it on AWS Lambda as well. As of like really recently, it got some support for that, and I'll speak more about it later. And yeah, I have a puppy named Boss. It's the joy of my life right now. And yeah, he doesn't like food. He likes to eat stuff that's not food. So I need to, keep removing stuff from his mouth all the time. And yeah, do some surfing as well for the fun and the exercise. And yeah, I think that's a lot about me already. Today, I'm here to talk about my case for lighter GraphQL client libraries. Which I think are missing, at least for some important languages. And yeah, also about the quiz, I'm going to be really nice and provide some hints. So if you see something that's orange, perhaps that will help you answer the quiz. So yeah, let's start how I got here and why I'm talking about the subject. Me and my team were building this app called Combase, which you can see in the image. So what is it? It's a customer support chat platform similar to Intercom, but more flexible. So you'll have agents chatting with customers. Just a second, I'm having some issues here. Okay, just a minor second. I messed things up. Okay. So yeah, it has a live chat widget, which you can integrate in a website or in native mobile apps. And it's open source. You can check it out on GitHub. I'll give more details later. And it also has a GraphQL API, of course, which is what we'll be talking about today. But like this platform you're looking at, I didn't build it. Other members of my team were responsible for the front end and the backend portions. Including the GraphQL API itself. So what did I do then? If I didn't build that platform and I didn't build the GraphQL API, what did I do? As I said earlier, my background is as an iOS engineer. So naturally, I was in charge of building the iOS SDK for it so that you can integrate your customer support chat inside native iOS apps for your users. And that mainly involved interfacing with the GraphQL API my other teammates built. But I also had this SDK. I had to keep this SDK as lightweight as possible. So increasing the size of the apps using the SDK wouldn't be much of an issue. And these requirements ultimately forced me to create our own GraphQL library for iOS, which I called Tiny GraphQL, and which is also open source. So it was really surprising to me that when I started building the SDK, there weren't any libraries out there that were light, that were simple for me to use as well. So, but yeah, I know that we shouldn't reinvent the wheel. That there are other libraries out there, but I just had unmet requirements. None of the wheels I found out there fit my requirements. They were either too heavy, they were unreliable, or had too many known issues. Some of them were using outdated syntax and tooling. Others were like outright unmaintained. And others just too much for my tiny use case, like caching, real-time code generation, all that sort of stuff I didn't need and would only add size and complexity to the SDK I was building. So apart from the unmet requirements, I was just excited to have some fun coding with this. And I'm sure some people out there feel the same, So one of the motivations was also to help out the community, other people that needed this kind of lighter weight library I was building. And of course, just I love learning new stuff. So, building a library for GraphQL, which is an API, a kind of API I've used before, but not a lot. So building something for it helped me understand a lot about it. So before we dive into what this new wheel looks like, let's look at the current state of the art library, which is, of course, Apollo iOS. And I'll give a few reasons why I couldn't use it and then go over them in detail. First thing I realized is that it takes too many steps to get from an empty project to making the first query. The second thing is that once you install it, it pulls too many sub-dependencies, like bloating your project right away. And then, of course, it helps lead to a large binary size so that maybe you're not able to afford if you have a size-restricted target. So Apple recently released, about the large binary size, Apple recently released a feature on iOS 14 called App Clips, and it's restricted to 10 megabytes. So you can't have a binary size of over 10 megabytes or else your app will get rejected. So that's also one of the reasons I built this library. And yeah, it also requires extra tooling and code generation to work, adding more complexity to your workflow. So you'll need to add some scripts to your you'll add some scripts to your CI to generate the schema and all that sort of stuff. Will increase your build time and other stuff. So what does it look like to get from an empty project to your first query using Apollo iOS? The first step is to install the library itself using any of the available dependency managers. So this will affect your project by adding 7 dependencies, and hopefully they're not incompatible with dependencies you're already using, because that can happen as well. Like maybe the Apollo iOS library will use some dependency that you're already using, and then that will clash and you won't be able to build your project unless you synchronize your dependencies. It will also add 7.2 megabytes to your app size, which may be a problem if you're targeting, as I said, the Apple's new app clips, which are restricted to 10 megabytes, and that's already 7.2. So that's more, that takes 72% of the size restriction already. So it's terrible for SDKs that want to be lightweight. And we'll also add an annoying 17 seconds to your build time. So every time you want to build your project from start, it takes 17 seconds more just for the Apollo iOS dependencies. And then you need to download your GraphQL schema, which can be part of the build sequence and adding even more time in those 17 seconds. And then you generate code from that schema, which can also be part of the build process, adding even more time. And then you create query files that the code generator turns into Swift classes, which you can then finally use that to run the Apollo client, to run the queries using the Apollo client. So some of these things might be totally worth it for very large projects with hundreds of models and queries and complex views, but that's not the case, and it wasn't the case for my project. So for my project, I didn't need or want 90% of this stuff. It was just like really getting in the way and making things slow for me. So using Apollo iOS was discarded like very early on. So what should I do then? Make raw requests through HTTP, because that's possible, right? You can run it and make an HTTP call with the GraphQL query encoded inside the body or inside the query string. But that's great. It looks terrible. It looks unreliable. But let's see why we shouldn't do that. First, you have to write the GraphQL code as a string, which can lead to all sorts of mistakes. and that can be caught during build time. Second, you need to be aware of some conventions. So like mutations need to be post requests with the GraphQL code in the body, while queries need to be a GET request with the GraphQL in the query stream. So, and finally, you also need to make sure you're using the correct encoding for the body and the query stream, and that you have the correct headers as well. So yeah, while that keeps things really lightweight and not as complex as using Apollo, it makes our life harder with the lack of syntax check and build time, which is going to have you make mistakes pretty often. And all the boilerplate code to make the GraphQL requests via HTTP, which beyond making a couple queries would become like really tedious really quickly. So yeah, and you get like really tired of making mistakes. So that's when I figured out I had no choice but to build my own library, and my goals were pretty clear. I wanted to keep the build time syntax check that Apollo had. I wanted to avoid like any HTTP boilerplate, so you know the user of the library doesn't need to know about HTTP. And I needed a very lightweight library, so with the least impact and binary size. So let's start building our library. It doesn't mean it's better than other existing libraries, but it will fit better with some mostly non-complex use cases. First, I tried building a domain-specific language inside Swift that matched the GraphQL code as closely as possible, so it would feel kind of familiar if you already knew GraphQL. I also included an HTTP request builder logic, which takes care of all the HTTP boring stuff. And the code is pretty small and has no sub-dependencies to build your project. So in fact, it only adds 100 kilobytes to your binary, so 70 times smaller than the Apollo library, and practically no concern if you're doing it in app clips. So what is Tiny GraphQL? It is essentially a library that lets you use pure Swift syntax to create valid GraphQL requests. First of all, it had to be really simple to use. It had to have no sub-dependencies, and it had to be open source, and you're able to check it out on GitHub, participate, and it has an incredibly low binary impact, as I said earlier. So let's compare the GraphQL syntax with the code that generates it. I'll use like examples straight from GitHub's GraphQL API because it's kind of like, you know, the hello world of GraphQL APIs, in my opinion. And as you can see, I turned the query keyword into a class named query on Swift. And there's also a similar class for mutation. The operation name goes in the first position of the initializer. The arguments of the operation become a dictionary in the second position of the initializer. And the list of fields are constructed using a function builder, which is just a fancy way in Swift of turning this sequence of fields instantiation statements into an array. So this is just syntactic sugar to not require commas and array brackets. It's also possible to simplify even further by just using strings directly for the fields. This is because there's an implicit conversion built in that will turn those strings into field objects. So it gets pretty similar to the original GraphQL code. Now, let's take a look into a more complex query with fields inside fields. So as you can see, it's possible to nest fields inside fields as much as you wish, but you'll need to include the field keyword if the field has children's arguments. It's just a limitation for now for the Swift language that I couldn't simplify that. And next, mutations. They're not much different from queries, except for the mutation class name. There's no nesting limit or anything like that, so you can nest arguments inside arguments. all you want for operations and fields as well. Okay, now that we've seen how the syntax kind of works, let's see how you use it in practice. So, of course, there is an instance that you need to create. The GraphQL, the tiny GraphQL class, it holds all the common logic that you'll most likely want for all your operations. So, for instance, the GraphQL endpoint, the headers for things like authorization and such. Actually, this class was renamed kind of a week ago to just GraphQL, but I didn't have time to change the slides. And again, we define the operation we want with that syntax we just went over. Next, we create a URL session request using the tiny GraphQL object. And finally, we use that request with the native URL session API, and you get your response. So it's as simple as that. So all this request stuff is pretty much native Swift from the native foundation library. And that's it. That's all you need to make a request with tiny GraphQL. It's incredible. I think that's we didn't have like a popular library that does this because it's just too limiting. Because we get like from 5 steps, 7 dependencies, 7.2 megabytes in binary size, and 17 seconds in build time, to just 2 steps, 1 dependency, 100 kilobytes in pack, and 0.5 seconds in build time. So does this mean that tiny GraphQL is better than Apollo? Well, let's say that we're kind of speaking about apples and oranges. You'd still probably better off with Apollo for complex apps. And if the increase in binary size is not an issue, and I'm certain you'd be better served by tiny GraphQL if you're building a simple app or an SDK, or if a binary size is a concern at all. You wouldn't want your SDK impact size too much, for example. So before we get to future plans and current blockers for the library, I just wanted to dive into the implementation a little bit. I know it's not a Swift event, but I really like the language, and I hope you'll enjoy how I achieve the syntax. So I'll go over the modeling of the library, the protocols, the structures, the syntax tricks I employed to make the DSL close to that of GraphQL, and also how I'm parsing those models into HTTP requests. So let's start with this example. Right at the beginning, you instantiate a query object, which could also be a mutation. It's pretty much the same. And here is the implementation of query. I'll just go over the interesting bits. So it's a structure that conforms to the query operation protocol. Protocol are kind of interfaces in other languages. And we do that here just to reuse the parsing logic. And if you want to create your own type-safe queries, which I'll talk a little bit about later, you can conform to that protocol and execute your custom query without any additional setup. And that protocol requires you to specify a type for the arguments. In this case, the query takes a dictionary of string to argument representable, and that's propagated down to the argument property and initializer. And argument representable is another protocol in tiny GraphQL, which any type that can be in the value of an argument needs to conform to. The library provides the implementation for string and dictionary. So you can nest dictionaries as values inside dictionaries to emulate custom object types in your GraphQL schema. So going back to the query structure, the next interesting bit is a function builder that takes field representable objects. So a function builder in Swift is essentially a syntactic sugar for declaring arrays. I'll show that. I'll show just what I mean. So it essentially lets us get rid of brackets and commas and get the syntax closer to that of GraphQL with the curly braces and no commas. Apart from that, just a second. So apart from that, we can also, I just got a little bit lost here, but yeah, I think that's pretty much what I wanted to say about that, how I achieved the syntax. And I wanted to say a little bit about the next steps in this library's evolution. So first, I need optional extensions at some point, like caching, real-time stuff that's possible with Apollo. And of course, we need the full GraphQL spec represented in the library, which is not done yet. And I need to improve the DSL as well. And also improve the type safety, so you can have it more and more type safe. And actually, there is some initial work done for type safety. So you can create your own query types by conforming to the query operation protocol. And you can specify the types of the arguments by creating a nested argument structure. So then the compiler will require that the arguments be correctly filled in. Just like here below, you actually need to have a login. Instead of like it being a dictionary and then you figuring out some mistake during running your app. And then you can use your query in a more type-safe way, of course. So, but this is still like early work. I'm still trying to simplify this in some ways that are not yet possible with Swift. And on that note, I wanted to talk about some blockers I reached with Swift and which features I'd like to see added to the language so I can improve the tiny GraphQL library. So first, I need more codable conformances. Codable is Swift's ability to serialize and deserialize strong types such as structures, enums, and classes. But for now, tuples don't conform to codable, and that would be perfect to improve the syntax around type-safe arguments. Also, enums with associated values aren't codable, and that would be perfect for the type-safe fields. So, and finally, type inference in function builder closure. So this would allow us to omit the class names inside the fields list, which would bring the syntax like really close to that of GraphQL. So if these features and maybe some more are implemented in Swift, this library will be like at its best in the future. So as you can see, like on the left, it's how it is right now. And on the right, it's how I'm envisioning it once like all the features are implemented in Swift. And like that's pretty much it for the meat of the talk. Like I hope you enjoyed it. And I'm just going to give some extra information about the Swift language, and that could be useful in the future for you. So as I said at first, the main language for iOS development is Swift, but it's also getting very popular for server-side development. It very recently gained an AWS Lambda runtime. And of course, it's open source. It's originally built by Apple, but it's evolving like very rapidly with the help of the community. And yeah, again, it has an open evolution process that's not dictated by Apple. The community can propose changes and all that. And many features were implemented by the community and not by Apple. Okay, so just sometimes for the links, I'd like you to please visit the Tiny GraphQL repository. It has lots of cool details, and you can check it out how it works more closely there. I'll give you actually a few seconds to take note of that link. Really go visit it. So github.com/getstream/tinygraphql, and I'll wait here 5 seconds. And also we have another open source project called Swift Lambda. So it's a launchpad for your AWS Lambdas written in Swift, and it has some samples like chatbots, content moderation, and more written in Swift and deployable with one command. I'll give you also a few seconds to take note of that link. So github.com/getstream/swift-lambda. And yeah, also some extra links here if you're interested in learning even more. Please visit my blog at dev.to/Cardoso. I have blog posts about some of these projects there and more. Also give you a few seconds to take note of that link, dev.to/Cardoso, and also my Twitter account that you can, I announce everything there, and I talk about some subjects about Swift that are not worthy of like a full blog post. So yeah, please follow me there. And that's pretty much it, actually, for the whole talk. Maybe that went fast. I don't know. So I hope you enjoyed it and that you've learned something today.
Awesome. Thanks. Thank you so much, Matheus. That was an awesome talk.